Hello students, Stride here again. Today is practice problem 11.2, where we will be doing some stoichiometric calculations. So here we have reaction CO2 gas plus 2LiOH solid reacts to form lithium carbonate solid plus H2O liquid. Problem says, on average, person exhales about 20 moles of CO2 per day. How many moles of LiOH would be required to maintain 2 astronauts in a spacecraft for 3 days? So we're looking at 20 moles per day. Per day. Yeah. 3 days. So we're going to multiply by 3 days. That would be 60 moles for 1 astronaut. So then we're going to need to take that times 2 astronauts. So we're going to end up needing 120 moles. So that's how much CO2 we're looking at. And the question asks how many moles of LiOH. So we're starting with 120 moles of CO2. And then here we're just going from moles to moles, so we just need a mole ratio. We're going from moles of CO2 to moles of LiOH. Our mole ratio is 2 to 1. So multiply, go canceling first, multiply, and we get 240 moles of LiOH being needed. Number 4, balance the equation, so we'll first do that. So I'll write it, KClO3 solid breaks down, decomposition reaction here to form KCl solid plus O2 gas. Initially, the KCl's are the same. We got O2, we got O3, so if I just balance those, I would need 3 O2s over here, 3 O3. I'll put a 2 in front of the KCl, and that means I'm going to need a 2 in front of this KCl. And we should have a balanced chemical equation now. And A asks how many moles of O2 are produced from 10 moles of the KClO3. So we got 10 moles here. We want to know how much O2. Question, moles. So we're looking at another just going from moles to moles. So it's a simple one-step problem where we just use a mole conversion. So we got 10 moles of KClO3. And we're just going to multiply that by the mole conversion, which is 2 moles of KClO3 for every 3 moles KClO2. Forgot to write moles in there. Moles of KClO3, cancel moles of KClO3. I'll go ahead and reduce the 2 and the 10 down and get a 5 up here, and that means we're going to have 15 moles O2. That'll be our answer for A. B, how many moles of KCl are produced using 3 moles of the KClO3? So this time we're going to have, instead of 10 here, we're going to have 3. And we want to know how many moles over here. So we start with 3 moles of KClO3. We multiply by the mole ratio, which will be 2 moles of KClO3 for every 2 moles of KCl. 2 moles of KCl. Moles cancel moles, 2 cancels 2. And then for B, we end up with 3 moles of KCl. C, how many moles of the potassium chlorate are needed to produce 50 moles of O2? So this time we're starting with 50 moles here, and we want to know this one. So very similar, we do 50 moles of O2. Our mole ratio is 3 moles of O2 for every 2 moles of KClO3. Moles cancel moles. We end up giving 100 divided by 3, which is about 33. But to put it in proper sig figs, we will just take it to 30 moles of the KClO3. And that's our answer for C. Number 5. Calculate the mass of sodium chloride produced when 5.50 moles of sodium reacts in excess chlorine gas. So the first thing we need is an equation. It says sodium reacts with chlorine. This will just be a simple synthesis reaction, and we get NaCl. Balancing it, we're going to need a 2 here and a 2 here. And they said, produce the mass of sodium chloride. So they said mass question. That means we're looking at grams. From 5.50 moles of sodium. So this time we're going to have to bring in a molar mass to be able to change the moles of sodium into grams of sodium. But we're still going to start with the 5.50 moles of sodium. I'm going to use a molar conversion, mole ratio, to change it into moles of sodium chloride. So we got 2 moles sodium chloride for every 2 moles of sodium. Moles, sodium cancel moles of sodium, 2 cancels 2. Now 1 mole of sodium chloride will be, using the periodic table and a calculator. You can add that up. Sodium is 22.99 to 2 decimal places. Chlorine, add that on. Chlorine is 35.45. Gives me a 58.44 grams of sodium chloride in a mole of sodium chloride. Moles, again, cancel moles. Add to a calculator, I just take that 58.44 times 5.5, and we get 321.42. Only supposed to have 3 sig figs, so we'll drop off the 4,2, and our answer is going to be 321 grams of sodium chloride is what is produced. Number 6. How many grams of chlorine must be reacted with excess sodium iodide to produce 6.00 moles of sodium chloride? They give us an equation, but we need to balance it. So we'll rewrite that equation. NaCl NaI. Oops. Copy it again. NaI plus Cl2 yields NaCl plus I2. Yeah, I left out the states of the things for what we're doing, and we're not going to affect our work. NAs are balanced. I's are not balanced, so to balance the I's, I'll put a 2 here. Now that changes the NAs. So I got 2 on one side, only 1 on the other, so we'll put a 2 in front of it. 2 NaCl. Cl's are balanced also. So 2's are balanced. And we're asked if it says to produce 6 moles of sodium chloride, so we're trying to get 6 moles here, and it says how many grams of chlorine gas. So we're looking for grams here. So we got another moles to grams problem. The first step again, we need to change the moles to moles. Moles of sodium chloride to moles of chlorine. So 6 moles of sodium chloride. Our mole ratio is going to be 2 moles of sodium chloride for every 1 mole of chlorine gas. Moles cancel moles. It's real simple. I'll just go ahead and take the 2 into the 6, make that a 3. Now, using a molar mass, 1 mole of chlorine is chlorine from the periodic table, 35.45. 5.45 times 2, 70.9. 0 grams of chlorine gas. Moles cancel moles. And that times 3. And we get 212.7. Our original equation said that was, a problem said that was actually 6.00 moles. I only wrote down to 6. 6.00, so 3 significant figures, so we'll round to 3 sig figs at 213 grams of chlorine gas needed. Very similar problem here. They give us equation, ask us to balance it. So Zn plus HCl yields ZnCl2 plus H2. Here you have a nice little single replacement reaction. Looks like the ZNs are okay. You've got 2 H's and 2 Cl's on one side, so if we just put a 2 in front of there, we will be balanced. And this time it says we're starting with 5 moles of zinc, 5.00 moles. And we're asked to calculate the mass of hydrochloric acid, so we want the mass of this. Question, again, in grams. So very similar to the last problem, 5 moles of zinc. A mole ratio will allow us to go from moles of zinc to moles of HCl, and 2 and 1. Cancel and cancel. And 1 mole of HCl is our calculator again, and a periodic table. And chlorine a few times here on this one. Chlorine at 35.45 plus oxygen at 1.01. Gives us 36.46 grams of HCl. Moles cancel the moles. We got 5 times 2 times 36.46. 5 times 2 is 10, so that's just going to move our decimal once. And we get 364.6. Two proper number sig figs. Should only keep 3 sig figs. So that'll be 365 grams of the HCl needed. Number 8. 4 little parts here. Balance each equation and solve the problem. So 4 little questions here. So we've got Mg plus HCl yields MgCl2 plus H2. And if we want to balance it, Mg's are balanced, H's are not balanced, Cl's are not balanced, and we just need a 2 in front of here. Always remember, first step is to balance. And then we need to, then it asks if we start with 40 grams of magnesium, 40.0 grams. We want to know how many grams of magnesium chloride. So I'm just going to put a G question. So this time I got a gram to gram problem. First change to 40 grams of magnesium into moles. So 1 mole of magnesium magnesium from the periodic table. We find that is 24.31 grams of magnesium. Grams cancel the grams. And then we know that there is 1 mole of magnesium for every 1 mole of magnesium chloride. Moles divide out to moles. And then we know 1 mole of magnesium chloride is, magnesium again was 24.31 plus 2 chlorines at 35.45 gives us 95.21 grams of magnesium chloride. Cancel those, and that leaves us 95.21. Now divide by 24.31 and multiply by 40. And we get 156 approximately. 156.65 plus a bunch of other digits. And to 3 sig figs, that would be 157 grams of MgCl2. B, C, and D, I will leave for you to work on yourself. If you run into problems, you can check with me. I am going to give you the answers right now, so you can check and see if you did them right, but I'll leave all the steps for you to fill in. B, the final answer is going to be 2.24 grams of copper. C is going to be 9.36 grams of HCl, and D is 25.1 grams of the silver phosphate. So there's the final 3 answers. If you do struggle with them, can't come up with those answers, check with me in study hall or in class, and we'll figure out what's going on with them. But that's all we have for this section, this little set of practice problems. Next time we'll be on practice problems 11.3. So that's all for now.